All right, let's get right into it, because today we're talking about a real game changer. It's an idea that tackles one of the most stubborn, frustrating problems in all of machine learning. We're going to look at a new kind of AI, one that can actually see the shape of information before it even starts to learn. You know that feeling, right? You get a cool new update for your smart speaker, you teach it a new trick, and then suddenly it can't remember how to do the simple stuff it's done 1,000 times before. It's not just you. That's a real and really annoying thing.
So yeah, you're not imagining it. This is a massive, well-known problem in the AI world, and it has a perfectly dramatic name for it: catastrophic forgetting. It's basically the reason AI can feel like it's taking one step forward and two steps back.
Okay, so let's break down what this forgetting problem really is, because it's not some minor bug. It's actually a fundamental flaw in the way a lot of AI models are built to learn.
Think about it like this. Imagine you spend a year learning French. You get really good at it. But then you decide to learn Spanish, and in the process, you totally forget every single word of French. That's literally what's happening inside these AI models. And it's a huge roadblock to creating AI that can actually learn and grow over time like we do.
And it gets worse. When you have an AI learning from lots of different places at once, what we call a distributed system, the problems just stack up. We're talking models losing up to 40% accuracy on things they used to know perfectly. They lose all sense of context, so critical information, say the signs of a really rare disease, just gets blended into a useless average. And all the different parts of the system, the nodes, spend way too much time just talking to each other instead of actually learning anything. It's a mess. So how has the industry been trying to fix this? Well, the methods we have right now are, let's just call them a clumsy patch. They kinda sorta work, but they create a whole new set of problems. This really lays it all out. The standard approach, something called Federated Averaging, forces every single part of the AI to sync up all the time. It creates this massive digital traffic jam. And get this, up to 80% of the training time is just spent on communication, not learning, just talking. Plus, it's based on this totally wrong assumption that all the data it's seeing is neat and similar. The real world, it's never like that. And this brings us to the breakthrough, the big idea that flips the whole problem on its head. What if, instead of trying to force the AI to remember better, we could teach it to see better in the first place? This is it. This is the heart of the whole thing. The system we're looking at today doesn't just blindly cram in new data. It takes a step back. It first analyzes the shape and the density of the new information to figure out what it is, to understand its context. It's all about perception before learning. Now, this isn't just some vague idea. The actual research paper spells it out. It uses a ton of jargon: LSH, hyperloglog, t-digest, hybrid consensus. But don't worry, what all that tech speak really describes is a super clever combination of tools that lets the AI see, scan, and work together in a totally new way. Let's unpack it. All right, so how does this thing actually work? What is the system's secret sauce? It boils down to a really smart three-step process. First up, smart grouping. It uses a technique to instantly sort new data into the right buckets. It's like a librarian who can tell if a book is about history or sci-fi just by glancing at the cover without having to read the whole thing. Then it has to find the crowds. It uses these incredibly fast scanning tools to look at all those buckets and see which ones are the biggest and most important. It's not about analyzing every single detail. It's about getting a quick, accurate picture of the main ideas. And finally, there's flexible teamwork. This is like a brilliant project manager that knows when the whole team needs to get in a room for a big meeting and when it's faster to let smaller groups just send quick text to each other to keep things moving. So that's the how. A system that sorts, scans, and syncs with intelligence. But what happens when you actually build it? Well, the results are pretty wild. Let's look at the numbers. First off, that digital traffic jam we talked about. This system cuts it by almost half. 48.2% less wasted time. Less wasted energy. That is huge. Next up, speed. It learns faster, 35% faster, especially on the messy, unpredictable kind of data you find out in the real world. It gets to the right answer quicker. And for me, this is the big one: accuracy. Because it understands the context, it makes nearly 70% fewer mistakes from mixing up different types of information. It knows how to keep things separate. And this chart really tells the whole story. When you test it on that messy, real-world data, the stuff older systems choke on, this new system is a whopping 27% more accurate. It's not just a small step up, it's playing a totally different sport. Okay, The numbers are impressive, for sure. But what does this actually mean for us? Why should we care? Let's talk about the real-world takeaway here. The possibilities are incredible. In healthcare, that 27% accuracy jump could mean spotting a rare disease earlier. For self-driving cars, it means shaving precious milliseconds off decision-making time, which could be the difference between a close call and a serious accident. For factories, it's about getting to almost perfect accuracy and spotting problems before they happen. And, maybe most importantly, it can do all of this without having to correct everyone's sensitive data in one central place. That is a massive win for privacy. So if you take one thing away from this, let it be this. What we're looking at is so much more than just a faster algorithm. It's a whole new way to think about building AI. We're finally moving away from AI that just memorizes and forgets, and toward an AI that can actually understand context, that gets nuance, and that can keep learning without wiping its own memory. Which leaves us with a pretty amazing question to chew on. Once we have AI that can learn from everything, everywhere, all at once, and never forget, what's next? What kind of impossible problems do we suddenly get to solve? What does that future even look like?